I suppose you can sum up the main issues into three categories: availability of resources, the time it takes to do stuff, and cost. Now, to understand that, you really need to look at the journey of creating and managing your data or data. So that's really broken up into three features. The first one is around data pipelining. So how do I take data, what transforms I need to execute it, and then where am I going to put that? But it's not just that, it's not just a business logic, it's about the hardened processes around that as well. So hardened processes such as, well, how do I do data lineage? How do I do archiving? How do I do metadata management? I've got to do deduping, I've got to do data cleaning. So all of these are hardened processes that need to be wrapped into it. The next feature is what we call data management. So, okay, so I've generated my data, I need to put it somewhere. Okay, so maintaining those assets, whether it's a database, maintaining schemas and tables when things change, or whether it's a partition or file system. And the third one is data governance. Okay, so when things go wrong, when I need to understand data management, when I need to fix data quality issues, who's going to do that? So the problem we have is, to do the data pipelining, we need really skilled data engineers, or we have a situation where we have lots of tools which do part of that puzzle. So either it's doing some of the E, or some of the T, or some of the L, or a combination of that. Likewise with the data management, we don't have a tool set which does everything. So we have a issue where we have data engineers, where we need really skilled data engineers doing really complex things. We don't have enough of them. And we have tool sets in order to deliver all of that data management lifecycle, that lifecycle of managing, creating our data assets. We need lots of tool sets to do that, which again means we need very skilled engineers which understand all those tool sets. So that's our biggest problem. Well, you really need to rationalize on the way we approach what products we use for their end-to-end lifecycle of creating and managing that data. And the best way to do that is using a tool set like ours. So instead of using several tool sets, you want to reduce the number of tool sets you have which do that end-to-end lifecycle. And that's where we come into play. So I've been kind of setting this environment for the last 25 years, managing organizations which do data architecture and data engineering, and I've always had the same problem. I need lots of engineers, which often comes out too expensive, and my projects overrun, and they cost too much. So therefore, we decided to come up with this product which consolidates all of those features that we need for the end-to-end creation and management of those data pipelines into one product. So as I've just explained, in terms of the life cycle of creating data and managing that data, we manage the whole thing. So our product will allow you to create data pipelines, first of all, okay? So it will allow for example, a non-technical person, like a data user, for example, to use the GUI front end to generate a data pipeline. So pull sources from several places, do the transformations on it. So whether that transformation is in SQL or whether it's Python, it's completely up to them, and then to output it. But because we are dynamically doing all the hardened processes as well, so around data lineage, around metadata management, around the mapping, and because all of those hardened processes are built directly into IOblend, what IOblend does is every time a data pipeline is generated, it automatically creates all those hardened processes. So what that means is, where I typically have a data engineer writing those hardened processes, I now can have my data user, or my data analyst, or my data scientist, creating those data pipelines. The other thing is, if you want to do streaming, you're using even more complex technology. So what our technology does, it goes, well actually, why is there a distinction between a batch data pipeline and a streaming data pipeline? So we combine the two. So it doesn't matter whether you're doing a streaming or whether you're doing a batch data pipeline, it's the same data pipeline. So we've simplified all of that, so it means that anyone can do it. So it means 80% of the work that typically a data engineer would have to do, which is the boring stuff, we can now get the data user to do. So we're democratizing the ability for them to control their own data and to use it. And now the data engineers can get on doing the really cool stuff that they like doing. So not only is it doing all that, and so we simplified everything, we've now brought the process down from where sometimes it can take 3 months to do a job, we're finding we can do it in 2 weeks. I think as a collective group within the data world, we need to start looking at trying to do things a little bit better. So don't always go with flow in terms of there's a new tool set and that's going to solve a problem. Try and take a step back and try and solve the problem before it gets there. So if you're looking at data quality, well really what you want to be trying to do is do the data quality before your data ends up in your database and trying to fix it afterwards, because life becomes really complex and expensive then. Big Data London, the great thing about this is that it's full of like-minded people who are all trying to do the same thing, optimize their usage of data and make the most out of it. So it's fantastic having conversations with people of the same mindset and sharing ideas. And some of it's not even about the product, it's just someone comes along and says, oh, I don't know how to do this, and well, why don't you try it this way? It's just having that conversation, it's really nice. And the second is because there's lots of people like us, it's a really good platform for us to launch our product.